How do halons impact the polar ozone layer? Imagine a giant shield protecting the Earth from harmful ultraviolet rays. This shield is the ozone layer, and it's especially thin over the polar regions during certain times of the year. Now, some human-made chemicals called halons have been quietly weakening this shield, especially in those cold, remote places. Halons are compounds that contain bromine, a very reactive element. They were mainly used in fire extinguishers because they can put out fires quickly. But when halons are released into the atmosphere, they don't stay there forever. Over time, they break down and releases bromine atoms into the stratosphere, the layer of the atmosphere where the ozone layer is found. Bromine is much more effective at destroying ozone than chlorine, which is found in other chemicals like chlorofluorocarbons. In fact, bromine from halons can be up to 16 times more destructive to ozone molecules. In the polar regions, especially over Antarctica and the Arctic, the cold temperatures cause the formation of polar stratospheric clouds. These clouds act like chemical reaction surfaces where stable bromine and chlorine compounds are turned into reactive forms. When sunlight returns after the long polar winter, it triggers reactions that rapidly break down ozone molecules. This process creates the famous ozone holes over Antarctica and significant thinning over the Arctic. Bromine from halons plays a key role in this process because it participates in catalytic cycles. These cycles involve bromine atoms repeatedly destroying ozone molecules, making the depletion much worse. Even though bromine is less common than chlorine, its reactions are more efficient at ozone destruction, especially in the cold, stable conditions of the polar vortex. Despite international efforts like the Montreal Protocol to stop producing halons, they still linger in the atmosphere. This is because halons have long lifetimes and are still used in some fire protection systems, especially in developing countries. These residual emissions continue to slow the recovery of the ozone layer over the poles. So, in simple terms, halons impact the polar ozone layer by releasing bromine atoms that cause rapid ozone destruction. This leads to larger and longer-lasting ozone holes, which allow more ultraviolet radiation to reach the Earth's surface in those regions. This increased ultraviolet exposure can harm ecosystems, damage crops, and affect human health. Protecting the ozone layer means reducing halon emissions and finding safer alternatives for fire extinguishing.